coral wages a constant battle against algae for space and dominance. On a healthy coral reef, it is a battle that the coral mostly wins. However, in recent decades, scientists and reef managers have noticed with alarm that entire coral reef ecosystems have been overgrown by algae. Familiar, colorful coral reefs quickly became unrecognizable, with only the algae-coated outlines of dead coral hinting at the reef's former bounty. Warming waters, agricultural pollution, or overfishing can all cause this sudden shift to algae dominance, but it is often a combination of factors that tip the scales in favor of the algae. This abrupt change in ecosystem type is called a phase shift, and a big part of conserving coral reefs is predicting when it might happen to a particular reef and how to prevent it. A recent study in French Polynesia helps us better understand how and why coral algal shifts happen. Imagine a marble balanced on top of a hill. If you nudge it gently, it will roll down the hill, but once at the bottom, it becomes much harder to return the marble to the top. Coral reefs that are overtaken by algae face a similar problem. Once the ecosystem has slipped into an algae dominance, it is much harder to get a healthy coral reef back. To learn more, scientists used two distinct parts of a coral reef in Moorea as a natural laboratory. The coral growing on Moorea's forereef, or the side of the reef closer to the ocean, had been very resilient and remained strong across years of natural disturbances. In the lagoon, however, patches of the reef had historically succumbed to algae after disturbances. To imitate an overfished coral reef, the researchers set up cages with different sized holes over portions of the reef. Small holes excluded larger algae-munching fish from swimming inside. Half of the cages contained coral, while the other half went over algae. By the end of the experiment, the scientists had learned that it was not just the hole size of the cages affecting whether or not algae grew inside, but whether the cage had started off with coral or algae inside. The researchers also tested how patches of the forereef and lagoon would react to algae removal. They removed either all, some, or none of the common type of algae from the experimental sites. Then, for several years, they tracked whether it grew back. The healthy algae-eating fish population on the forereef ensured that the algae did not grow back on those test sites. In the lagoon, the common algae made a full recovery within a year at the sites where some of it had been removed. It was only at sites where scientists had completely removed algae from the lagoon that it did not grow back right away. The study confirmed what scientists had previously suspected but been unable to test, that returning an area to the exact same environmental conditions before algae took over often is not enough to bring back a coral reef. In the hill analogy, it is not enough to push the ecosystem back to the top of the hill. Facing challenges like ocean acidification, a warming ocean, and overfishing mean that coral reefs need all of the extra help that they can get. Needing to recover coral reefs overrun by algae may sound like yet more bad news on an endless list of problems facing coral reefs, but the study authors hope that the opposite may be true. If managers and scientists can predict the range of conditions where either coral or algae can dominate, they will be better armed to protect existing coral reefs and can help recovery when possible. That way, we can focus on preserving the coral reefs most likely to resist an algae takeover. This post was originally made on September 2, 2019 by Sierra Garcia. It was titled, "Can Coral Reefs Strangled by Algae Recover?" and featured a paper by Schmidt et al. 2019 titled, "Experimental Support for Alternative Attractors on Coral Reefs." This has been Oceanbites Out Loud. Check out oceanbites.org for this post and other neat posts. Thanks for listening.